Hello, everyone. I'm your host, Kevin from ARC and Codementor. Thank you for taking this time to join us today for our Leveraging Machine Learning and MLOps for the Modern Data World talk brought to you by ARC. So ARC, we connect great developers with companies around the world. If you'd love to learn more about us, we'll be sharing the link in the chat. And today we will be learning from Billy, Gareth, and to make sure you take full advantage of this talk, feel free to drop all your questions for our speaker in the Q&A section. There's a Q&A section here on the bottom. You can click that and write your questions, and we'll answer them by the end of the talk. And don't worry about taking notes immediately. We'll be sending the recording to all the attendees. And so let's welcome today our special guest. Here with us is Billy Gareth, data scientist at Xetova, NVIDIA Jetson AI ambassador. Billy is a bright and ambitious data scientist and MLE with a successful background of deriving solutions wherever problems exist, essentially building reliable, scalable, maintainable, and adaptable data science and machine learning solutions. So without further ado, Billy, the stage is yours.
My name is Billy. I'll have to leave this here. My name is Billy Gareth. I'm a data scientist. Thank you so much for joining. Thank you for sparing your time for this session. I hope you'll pick up a thing or two. So let's just start right away. Yeah. Here you go. Yeah, so basically today's session will be about streamlining the process of taking ML models to production. So the notion is when you join data science or machine learning as a practitioner, you'd always get to build models and use them for prediction once in a while. And even in your enterprise or organization, you're expected just to make predictions, but then when it comes to scalability, now only a few minds get to pick up on what is required and how the process can be smoothened. So this today is just a process of handling the operationalization of machine learning production. So when you talk about ML-enabled system, just to give a breakdown, more often than not, we are required to define data requirements for all our projects. Then these data requirements are passed through the data engineering team for evaluation, and then picked up, they are sourced, they are collected, then provided as curated data to address your solution. So the ML engineering team afterwards can now get to build a model, and after comparing the models and finding the best model for the problem, now we have the deployed model pushed to the app engineering. It could be web, to be used in a website, or to be used in an application, or just to be used in an SQL. The results could also be pushed to an SQL database or something. So, and with the understanding of the MLOps lifecycle, basically, when you start with the ML development, majorly, you are just required to identify what kind of problems you are required to have, what kind of data source you are required to have, and which kind of problems will you have to be addressing using the data source that have been provided. So when you move to the training operationalization, now you work on training your models with the best parameters and evaluation on what kind of metrics that are required. Then after training operationalization, which is the pipeline, now you go to continuous training. Here, now you are required to make sure that the model that you have keeps training on the data as it comes in, because there tends to be a data drift, so that in such a way that the model, when it was being deployed, the accuracy was a bit high, but after being exposed to the real world data, now the test accuracy starts to become low. So continuous training helps to merge that and remove the trade-off between that. Then model deployment now deploys your model to a source, to a certain location. Then serving now allows global resources to be, or even requests to be made to the model, and returns your predictions. Then monitoring now evaluates whether your model is according to the required standards. It could be a precision score or a recall or F1 score, or even the mean absolute errors. So the reason as to why you need to understand this is because with the growing data space right now, we have a lot of ingredients and things that facilitate this process. So things like large data sets will require you to shift from the way you process data when it's only 12,000 rows to when now we are handling 1 million records. Processing won't be the same, or else your application or even the whole operation will be inefficient or could be shut down. Then there are also a lot of inexpensive on-demand compute resources from companies like Google that support the machine learning ideation and even the implementation process. Then there is specialized accelerators for ML. These are offered from majorly companies like NVIDIA, just having certain resources or even programs to facilitate those who are new into ML, and even those who require more demand or compute resources. Then we also have rapid advances in different ML research fields. So you find that in a couple of research fields that are integrated with ML, there are things that now start becoming majorly interconnected. So you find that machine learning algorithm that you use in your phone is also used like in your laptop. Let's say a YouTube algorithm, one in your phone, one in your laptop. Things like federated learning when it comes to handling robotics and continuous training. So things of that nature now require you to understand the life cycle and how to move in that direction. Then now this is just a niche on a breakdown on how the niche operates. Sitting within the data and model management, now you can start from the ML development. Then you'll have code and config, which is the output. So the yellows are the outputs, and these are the steps. The blue is now the whole operations, and then we have a step which aids in starting the next step. So the code and configurations will help in building the training pipeline, which is under the training operationalization, which will have as an output. Then we'll have now the training pipeline being used in the continuous training process, which will result in a good registered model. After we register it, now we take it, package it under the model deployment. Then after that, now we serve predictions. Then after that, we use the logs to monitor. So the logs could be AUC, the logs could be RMSE, the logs could be MAE, and all that stuff. Then after that, now we have, this is another breakdown of the ML development process, but from the whole perspective, where we have data engineering, starting with the data set and feature repository. So feature repository, most are used to data set only. Feature repos help to reduce a lot of processing or pre-computing when you are doing a lot of handling a lot of high transactional data, such that when it comes to features, you already extract them and store them with different data points. So anytime the queries are made to the backend, we don't have to execute the whole thing to extract features. So that you just go pick the data set combined with the features. Then now that makes the whole data set an output. Then after that, now here sits the experimentation and prototyping. Here you'll have your Jupyter notebook with the problem definition. You select the data that you require, you exploit, conduct a bit of EDA, exploratory data analysis, feature engineering. Then now you do your model prototyping, then validate. Then if you find that in some way the things are really not adding up in terms of the problem definition and the output expected, you can make this an iterative process and just loop and try to find the best way to address a problem. Then afterwards, this now provides three outputs. We'll have a trained model from that operation. We'll have parameters, metrics, and annotations from the model. We'll also have code and config. This is for version control, in such a way that now you know the model version, the data version, and now when you do a lot of retraining, or when you start to automate the training process, now you'll have the versions of the model, the data. You'll know this model was trained with this data, how did it perform, and all that. Then this is the training operationalization process. When you find this, CI/CD could be a GitHub trigger in such a way that it handles workflow. It could be something like whenever code is pushed to this repo, start the whole retraining process. Then after it's trained, we version control the whole thing. Then we have the training pipeline, come up with the ML pipelines. So this could be staging. For those who don't know staging, it could be any experiment or model that isn't yet used in production. So you could stage a model, and when you use it in production, now it's removed from the local storage to a remote storage and used to serve requests whenever requests are made to the application. Then we'll have pipeline components and software artifacts, which are the details. So to conclude, this is ML. One of the things that you can see here, not all these are MLOps tools. So I'll just try to narrow down which kind of tools that are specifically like handling the MLOps more efficiently. So tools like DVC is used for data versioning. Same to Pachyderm here. And then we have Spark. This is for streaming. Airflow, this is for streaming. Then here is NVIDIA Rapids. One of the reasons as to why NVIDIA Rapids is curated is unlike the traditional way of handling data, where we process data in terms of rows and handling data just in terms of rows. Let's say you process this and this rows, and then that's now handled by the CPU or something of that sort. Rapids now handles this data in terms of the column. It has a columnar structure, so the data processing will be X times faster. It could be in fact, the bigger the data, the faster it is compared to pandas and all those things that handle the data traditionally. So Rapids is specifically curated for data science that's accelerated. And also we'll have these are the frameworks that we have for training. We'll have weights and biases. This is for tuning. We'll have TensorBoard. We'll have MLFlow. We'll have TensorRT, which is for high-end deep learning. It ensures just in such a way you will have low latency and high throughput. Then there's CI testing and all that. So I'd want to do a quick demo for you. Let me do a quick demo. I could share my entire screen to make this whole process easy. Yeah, okay. Can you see my screen? Kevin, you can confirm.
Yes, we can see your screen now.
Okay, that's fine. So I'll just use an example of MLFlow, which I've shown there. So MLFlow, we have an example of MLFlow here. Then now you could use, let me just pick something like this. Now you see the way this code is structured. This is the way code essentially is usually structured in production. So in such a way, you'll have the evaluation metrics of a model, which is mean squared error, mean absolute error. These are the metrics that are weighted here and now evaluated. So when it comes to training, you'll see the train test data for the X and Y. Y is usually the targeted column, and which is the predicted column essentially. And now you'll see tends to log the accuracy metrics, which is when you train a model, you require the low RMSE, you require your absolute error also to be low, R2 coefficient to be low. So in such a way, you could have, let me put up my screen. You could have, whenever you run this train.py file, it runs a training. It automatically trains because it's a train file. So let's just use a terminal, a quick terminal here. So every time you run, you can see you pass an alpha and L1 ratio. if you remove this, there is one that's already automatically has been defined within that file. So for example, here you see L1 and alpha ratio. So this is what you now need to run. Every time you are training, you specify an alpha and L1 ratio. So you could know the where it's supposed to range. It could be 0 to 1. So it could be you specify randomly 0.8. So like here, I could do 0.8 as alpha and 0.75 as L1 ratio. Then I'll run that. Then afterwards, you'll see it's an elastic net model, which is used for regression. So afterwards, it retrains and now gives you RMSE and MAE and R2 scores. So you could now see a trend 0.79. Now it's higher, 0.833, and we need this to be a bit low. So it needs to keep going down. So MLFlow, which is one of the tools, will enable you to have all this also in a UI if you don't need to look at the terminal. So within the same space, you could reference this later on in the official website so that you find the whole flow easily understandable. So when you run MLFlow UI, it should just pop up a UI for you. Then you'll now be able to monitor all these metrics as they flow in. So this is one of the tools that tend to make your work easy when it comes to just versioning your code, understanding the code metrics, evaluating your model, and even monitoring. So let me just pop up my Chrome again. Just have this. So this is the MLFlow UI. There we go. These are the two trains that we've had recently. So I could just shrink this, and now you'll see the metrics. You'll see the parameters that were provided earlier on, alpha and L1 ratio. You could also see the duration it took to train each of these. The user, this is now when you are using multiple users, you'll have two different people. So MLFlow has been integrated with tools like Databricks so that you handle a lot of processes at a go, even in cloud environment. So it has been integrated with majority of the cloud services. And this is one of the let me say one of the projects like that help you speed up your MLOps operationalization journey. So you can see the model. There is a version space here. You could version these models to version 1, version 2, and also afterwards you could just click on a model. You could register the model, select the model, create a new model. You can see for me, I have a cash revenue model registered. But that's not for now. Then it will give you automatically Spark data frame predictions, Pandas data frame predictions, outline. This is how you use your model. So this is the model location. So that's why it gives you an automatic like absolute field in this logged model space. So things of this type now help to ease up your work. You could look at the ML model, the Conda YAML file that you'll need to use in prod. If you need to download the model and use the serialized model and use it in a web application, there you go. You can just click on download. Then Python environment YAML file. The requirements, if you need to install this again and run everything, then you could now this is for experiments. Then you could go to models and find staging and production. So you are able to move one let me say model from staging to production and shift them. So let's say you've trained cash revenue model with the revenue model. Then you want to have revenue model in production. You can just move. You can just after training and versioning, you could just click on stage, then move staging from staging to production. You can easily do it in this UI, and you can also do it in your command line or even your Jupyter notebook. So this is one of the tools that I was talking about There is also Prefect, which I highly recommend. Prefect majorly helps you run code in segmentation. So you'll have the code as tasks and flows. So tasks are in simple English, children. They are children of flows. So tasks exist within a flow. So for example, in this code, it will just, every time you run a flow, the first thing that you do is handle which task are you specifying, because this call API is from this task above here. So the flows will run and execute, then show you, they run, then execute the tasks that have been referenced within themselves. So this will also enable you to orchestrate workflows for your machine learning projects. You can also have a UI later on here for the flow runs. For the flows, you will see the flows that have failed, those that have passed, and the outputs and all those. You could have also deployments and work queues and blocks. So this is one of the tools that also I'd recommend, because now when you use it and it comes in handy with the MLFlow, it could also help you to just keep on regenerating. Let me say metrics could be the alpha and L1 ratio. Now you'll not have to specify them in the terminal. You'll just have, let me say, a random function that's generating them and testing them every time. So even when you're away from your laptop, the code and the model still keeps running, retraining, and just evaluation is done. You could also have a function that evaluates your models and picks the highest. So if you automate that function, you could, Prefect allows you to also have schedulers. So you can have that function run, like, let's say, each and every 1 hour, or even each and every, after every half an hour, or even every midnight, so things of that sort. So I think there are a lot. There is DVC, there's DVC, there's also a lot when it comes to how would be cloud services. So you'll find a lot of integration. Some will even be inbuilt in such a way that they reference for you the locations of your files and even the data. So for example, when you use SageMaker and you use AWS in correlation with the MLFlow, you'll have certain things already auto-picked for you. So the process will be eased out. So basically, that's it from me. If you have any questions, I'll take them now.
Okay, great. Yeah, thank you for your presentation, Billy. So let's read some questions from the audience today. So the first question we will read here is from Kamundia. So he is asking, he or she's asking, what are software artifacts? Hi, Billy. Did you hear the question?
Yeah. Sorry. Okay. Software artifacts. These are things that, how do I put it? These are just outputs of an experiment. So they help you. Let me give an example by sharing my screen. I think it will be easier, because for these we have artifacts. So specifically for, okay, I'm not sharing my screen. Specifically for enter screen, sorry. Okay. Specifically for machine learning, your artifacts are here. So this is the description. Then for every experiment, there are always artifacts for the model that you have. So these are dependencies, things that will help you just recreate the whole process. So if you are now trying to move the experiment from here locally and have it on a cloud resource, it will help you just to rebuild the whole thing without missing anything. You'll have your model already serialized. You'll have your YAML file, both for Python environments and for Conda environments. You'll have your ML model. Artifact, now you'll have its path, you'll have the time it's created. It comes with such details. So this is artifacts. Now, when you talk about artifacts in machine learning, this highlights the whole process. Yeah.
Okay, great. Yeah, thank you, Billy. Now, yeah, we'll have some more questions. Keep on, yes, keep on adding questions. Feel free to add more questions. And the next question is, where would you categorize the use of Docker, data training, evaluation, deployment, and is it used as often?
Yeah, the use of Docker in data training. Okay, for Docker, it's majorly for containerization. So it's majorly you don't really specify it when it comes to now your model training and all that, but it helps you to come up with containers that already are an environment for your models to be run. So I'm trying to get the question. Just okay. Here's the Q&A. So essentially, when you do your training, evaluation, and deployment, Docker really comes in when it comes to deployment, because it creates the images which create the container for you just to have an environment where your models run. But majorly, it has nothing to do with training and evaluation unless you are talking about the environment. It's just how to package your machine learning projects. So that's why it comes in handy majorly. Yeah.
Oh, okay.
And it's used very often. It's used so much. You need Docker for almost every project that require you to scale. Yeah.
Oh, for scaling, yeah, quite often.
Yeah.
Okay, that's great. Yeah, I have a question for you, Billy.
Yeah.
What's the one piece of advice that you wish you'd known 1 year ago?
1 year ago. Okay. I haven't thought about it so much, but I think one piece of advice that I would want to know when joining essentially data science and machine learning was to understand the machine learning operationalization process, because this is essentially it just brings out your business understanding in terms of problem solving right to the output and what the business tends to achieve at the very end. So it helps you maybe curate a lot of steps even without starting. You'll need to know, like, this is what I need to do. These are the tools that I need to use. This will help my model to work in this and this way. And also, you'll know like which kinds of models will require a lot of compute power, and is it worth the risk? Because sometimes you use a lot of machine learning for things that are not machine learning oriented. So that's one of the things that I think I should have incorporated earlier on.
Sure. Yeah. Thank you. Yes,
Yeah.
and answering Francis' questions. Yes, this session will be recorded, and we will be sending the recording to all who signed up for the session. And yeah, Billy, I have another question. So, what was your most recent development panic moment, and how did you end up handling it? Is there some recent
Panic.
panic moment which you could share?
Yeah.
Yeah. Yeah.
I don't think I have any, to be honest.
Okay.
Yeah, I usually do data for fun. Data science is
Mhm.
essentially the whole thing for fun. So anything that would be a panic moment for me would be a moment of just going back to study and knowing something new, a tool or something, and advancing. So for me, I've never seen any huge risks, or even in terms of panic or a push down moment. But then I think one of the things that people would really face would be to try and understand everything when it comes to now the mathematical or statistical side of data science. So I think the best thing to do is to understand the whole process than to get to cram the code, just to cram the code. It's better to understand how the code works than to cram the code. I think that is majorly what people, there are people who try to even master how data training is done. You could just go and copy that from scikit-learn website or something and paste it. So don't really focus on how the whole process works. Like, you now start cramming how these things will work. You need to have an idea on how you could do better training. Let me say using your loops, or even your how do we put it, your while functions and all that. But you don't need to now have the context. The context will always be in the documentation. So just understand how things work essentially in data. That will help a lot. Yeah,
Okay, great. And how about, what are those moments, as you're working as a data science that make you think, wow, I love my job or my field so much?
Yeah, in data, everything you touch is usually used to either improve a business or even ideate a process for a business or even makes the process of living for someone else easier in terms of how they handle their daily operations. It could be how they go about insurance or how they go about their credit ratings and all that. So what makes me happy about this is just understanding the whole process will be used by someone or will influence someone's life, and it could either make it easier or even make it more complicated. So mine is just to have the whole process to be as beneficial as possible when it comes to using the models in a website or wherever it is, just to have the best product and expect that your users will have constant good feedback. Yeah, because it will impact businesses each and every time that you give a report or any output. Yeah.
Yeah, that's great. The impact that you can bring.
Yeah.
Okay. Well, yeah, we have another question here. What would you advise you would give someone who's looking to apply for a data science or ML job role? It could be coding skills, tools, soft skills. Yeah, any advice would you give to someone who would like to apply for these kinds of jobs?
Yeah, basically, when it comes to job application, one of the things that someone needs to do is apply frequently and make sure your soft skills are top notch. Even if your coding skills are not as good, how you relate to people, I think, for me, with the leads that I've had, the heads of data and all those, what I think they look for is usually the soft skills. How you can work as a team. Is this person confident enough to just now give the communication? Because when you do data science, uh, people will now assume that we are now programmers. Data science is majorly interpersonal, so it needs you to have a lot of disciplines that you've mastered. So in that way, you can call it interdisciplinary. So you could be talking to project managers and giving them an output, or even product managers, so that you explain how the product relates to your code. So you need to understand how you communicate and relay information, and also your coding skills. Just make them as good as possible. But majorly for me, I'd go with the soft skills and also understanding the latest tools. This will come in handy when it comes to how frequently you learn your data skills. So that will always check out the adaptability field that's checked in the interviews. So the more tools you know and how they handle the processes, even better. Yeah.
Yeah, I agree with you. Soft skills are very important, especially as you're working remotely with other
Yeah.
people around the world. That's very important. Yeah.
Yeah.
Okay, we have another question from Felix. How do I start studying machine learning, and what roadmaps is there? Yeah, any roadmaps you could share? Yeah, Billy.
I saw someone give a roadmap yesterday on Twitter, and it was so simple. So I'd like to put, though it's not scientific, so you could start with any process, but I'd like to put statistics first of all, but not so much in-depth statistics. Just understand the calculus, the basic calculus, like what is linear regression, how things happen there, gradient descent. You don't have to understand the mathematical formula. Just understand how the whole concepts work. Then you'll also, after now learning that's the core part of statistics, that will help you to either do the traditional machine learning or even advance with deep learning. So either way, whichever problem that you are faced with and whichever solution that you expected to come up with, you'll know like with the statistical background, how it will be handled. Then after statistics, now just a slight, it's not too much statistics. Be careful of that. Don't have that. So after that, now you can move to now start doing programming language. Now you could implement your statistics in programming language. Just compute, let's say like the function that could be used in the last layer of a model, just compute that, or even compute a mean of a whole Excel file or something. So after we've started doing now handling, let's say for example Python, because I'm biased with this, so you could take Python, have that background of statistics, start using it on files and that. After that, I'd recommend you also do SQL. SQL will help you to retrieve data. So if with the data science, when there is no data, you are doing nothing, because the whole field relies on data. So you need to know how to collect it. You can do scrapping, you could do SQL, whichever, provided you have one that makes you get hold of data. So after that, now you start on now the others, now training machine learning models. After training machine learning models with the whole concept now of MLOps, you can now start talking about scalability. And I think after that there's nothing more. I think the next wave of machine learning could be things now to do with real-time machine learning and streaming machine learning. So that's a whole topic for another day. But there are things after you've now reached training models and gone a step further to MLOps. I think for now you'll be good in terms of being a machine learning engineer. But when it comes to data science, you'll need a lot of data analytics, data analytical skills, and a bit of modeling. Yeah, but don't forget the SQL. Nobody even expects the SQL questions in an interview.
Yeah, SQL. Okay. Yeah. So to wrap things up, I have a fun question for you, Billy. What's something unexpected, except to you, in the data science field, that will happen in the data science in the next 15 years? Yeah, something unexpected that you expect to happen.
Yeah. Something unexpected. I think. I think for me, I've always seen data and machine learning moving towards a lot of robotics or something. I know I've built projects on robotics. I don't have a background in engineering or something, but it's my fun side of work. I see a lot of robotics coming in handy in the near future. A lot of the repetitive things will now be all automated. We'll now be pressing screens, which will already use the trained model. So the job will not be on just having, let's say, providing output, but the job could be even just knowing how the ML models that you build now could help a business. So that's why it's always important to have the whole picture. As one of the directors at NVIDIA usually say, ML is more likely to be invisible in such a way that you'll use, it will be on the background. You won't even know where ML is used or not. So case in point is, let's say, the autocomplete when you are typing in your keyboard on your phone. A number of people could not even know that that's machine learning in some cases. People think it's just searching for words on the internet and using that. So that's the extent of invisibility that I see. A lot of concepts and activities that will be there will use ML, but majorly on the background, it won't be as visible and talked of as much. Yeah,
I like that. Invisibility, but will be helping us live our lives.
Yeah.
That's great. Okay, thank you, everyone. So that's a wrap. Thank you so much for joining. We've learned a lot with Billy today. And if you want to follow Billy in his social medias, you can follow his Twitter and LinkedIn. I share that in the chat box. And thank you again, and hope to see you all soon. Have a great day.
Thank you so much. Bye-bye.
Bye.